Hello everyone, welcome to my group final presentation. And this is Xiaoxue and my groupmate is Yuhan. Today we will be presenting an analysis of electricity usage and carbon emission in India. This presentation aims to provide a comprehensive understanding of the patterns and impacts of electricity consumptions and its associated carbon emissions across various states and regions in India. Next page, please. So this mean data we are analyzing contains 16,599 rows with six key fields: state, region, latitude, longitude, date, and usage. The state means a represented different state with India. Regions is classified of area into bordering regions. Latitude and longitude is geographic coordination for mapping. And date is time point for the data collection. Usage is amount of electricity usage recorded. Next page, please.
Let's begin with a general overview of electricity usage across different states and the regions. On this map, we see the distribution of electricity usage across different states in India. The size of the circle represents the sum of electricity usage. However, the color of indicate different states. From this map, it is strongly show that states like Maharashtra and the Uttar Pradesh and the Tamil Nadu have a high electricity usage. Shown by a large circle, this high usage can be contributed to the high population density and the significant industrial activities in these states. In contrast, states like Arunachal Pradesh and Missouri shows a lower electricity usage, indicate that by smaller circle, these states have a lower population densities and less industrial activities. To further explain the distribution of electricity usage, here is a bar chart that shows electricity consumption by states. This chart reinforces our previous observation. Maharashtra has highest electricity usage with 217,080 units, followed by the Uttar Pradesh and the Tamil Nadu. The high usage in this state align like their higher population densities and industrial activities. However, states like Arunachal Pradesh and the Missouri had a much lower usage, reflecting their lower population and less industrialization.
So next, let's dive into the training in electricity usage over the given time period. This line graph illustrates the electricity usage training over time. We observe some noticeable spikes and drops in usage. For instance, there is a significant peak on a specific date with the usage of 6,395 units. Such variations could be due to the seasonal demand, special event, or industrial activities. Generally, the pattern is fluctuating with certain periods exhibiting higher usage than others. Next page, please. Now let's compare the electricity usage across in different regions. Here we have a bar chart showing the electricity usage by regions. It is apparent that the western region has a higher electricity usage, followed by the north region and the south region. The high usage in the west region can be attributed into the presence of major industry hub and high population density. On the other hand, the Northeast region exhibits the lowest usage, reflecting its lower population and less industrial activities. Next page, please.
From this map, it is evident that states like Maharashtra, Karnataka, and Tamil Nadu have higher carbon emission as indicated by a large circle. This high emission can be attributed to the high population density and the significant industrial activities in these states. In contrast, states like Arunachal Pradesh and Mizoram and Manipur shows lower carbon emission indicated by smaller circle. These states have lower population densities and less industrial activity, contributing to their lower emission level. The varying size of the circle across the map reflect the difference in carbon emission among the states, highlighting the impact of both population and industrial activities on the emission levels. Also, this slide shows the trend in the carbon emission over time. Initially, emission fluctuated around 1.1 million units, peaking around mid-2019 at approximately 1.3 million units. Following this peak, emission declined steadily towards the end of 2019, dropping below 1 million units. In 2020, emission experienced significant variability, with noticeable drops and recoveries. It eventually stabilized around 1.1 units by the end of the year. This is for Xiaoxue.
Moving on, let's examine the carbon emissions by power generation type for each state. This bar chart illustrates the contribution of different power generation types to the total carbon emissions in each state. States like Chhattisgarh and Maharashtra have significant emissions from fossil fuel. In contrast, states like Tamil Nadu and Karnataka has higher contribution from renewable source, demonstrating and a more sustainable approach to the power generation. Next page, please. This pie chart provides a breakdown of the percentage of carbon emissions by power generation type. This majority of carbon emissions come from a fossil fuel and coal, which demonstrating the energy's landscape. Renewable energy sources such as solar, wind, and hydro contribute significantly less to the carbon emissions. This chart underscores the importance of transitioning to clear energy source to reduce overall emission and mitigate the impact of climate change. Next page, please.
We can observe a direct correlation between electricity usage and carbon emission in many states. For example, Maharashtra, which has the highest electricity usage, also showed the high carbon emission. This is effective, like relying on the fossil fuel or for the energy production in these states. In contrast, states with lower electricity usage, such as Arunachal Pradesh, have a correspondingly lower carbon emission. The correlation between carbon emission and electricity usage underscore the crucial need to the shift towards renewable energy sources to achieve sustainable development. In conclusion, our analysis of electricity usage and carbon emission provide valuable insight into the energy landscape of India. The data highlights the significant role of industrial activity and the population density in driving the electricity consumption and carbon emission. The correlation between electricity usage and carbon emission underscore the crucial need for a transition to cleaning the 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 energy sources, impacting the place in the promote renewable energy and enhance energy efficiency can pave the way for sustainable development in India. Thank you for your time and attention. We're now open to any question you may have to regarding to our presentation. And your feedback and inquiry are highly appreciated to us. Thank you.
Thank you.